Good afternoon, my YouTube viewers. It's Crystal here. I'm here this afternoon because I want to do a code preview for you. And basically, it's a code review for Women in Data Science Datathon 2022. And I missed the code review. I missed the Datathon, so I didn't get to do it. But basically, what it is they're trying to encourage women to get into the field of data science. And so, in order to go into this Excellence in Research Award Phase 2, you have to have done the Women in Data Science Datathon. So even though I missed it, I did it as a late submission. And it's talking about climate change and things like that. So that's what it's discussing. So this is just a lot of words, and I'm not going to read it, but you can go onto the Kaggle data site and you can read it yourself, because it's a lot to read, and we really want to get to the code review, don't we? So let's just look at this Women in Data Science website. It says data analysis can be completed using your preferred tools. Tutorials, sample code, and other resources will be posted throughout the competition in the Women in Data Science website and on the Kaggle web discussion forums. So I don't go into the Kaggle discussion forums a lot because I'm normally just coding, but I'm sure if I took the time to go onto the discussion forum, I'm sure I would find out some information about coding. But this is your Women in Data Science Datathon resources, and so they give you lots of information about this Datathon. But basically, it's just to try to encourage more women to actually get into data science. So now that you know where this Women in Data Science Datathon competition is, what we're going to do is we're actually going to do the code review. So I've had 9 views, and I've been working on it all day long as a late submission. And I've been using different models. I used linear regression. I didn't do very well on that. I used His gradient boosting regressor. I didn't do very well on that. And then I used, I think it was extra trees, and I didn't do fantastic with that, but I did better on extra trees than I did on His gradient boost regressor, and also linear regression. So I decided to leave it like that. I will tell you that my score was a 57 as a private score and a 56 as a public score. And if you look on the, we'll look on the leaderboard. It says jump to your position on the leaderboard. And the best score was 17. So I scored approximately 40 points less than the best score. But I think that this was like a really big data set, and because it was a really big data set, it was difficult to use models from sklearn, because I was reading somewhere that said that sklearn is just like more like a toy models, and so sklearn isn't really suitable for large data sets that you would have to use like PyTorch or TensorFlow or something like that, and I didn't want to do that. I could go back and put it on PyTorch because I just know a tiny little bit about PyTorch. I actually took a PyTorch course, but PyTorch is difficult. But I decided not to. I mean, I might go back and just try to improve my score with the linear regression for PyTorch. But it is very difficult. It's very hard. And so sklearn models are not designed for large data sets. So I used an sklearn model, and I didn't do very well on that. So let's see, maybe if I'm feel like I've got some extra time, I'll try to use PyTorch, see how it goes. So the first thing that we did was we wrote the program in the Kaggle Jupyter notebook, because this is a submission that we're going to submit to Kaggle for scoring, and I submitted it for scoring, and you can tell that my score wasn't that high, but nevertheless I'm going to do a code review for what I did anyway. So when we created our program, what we want to do is we want to import our libraries. In this instance, we imported NumPy, Pandas, Matplotlib, PyPlot, SPLT, and Seedworm. So NumPy is a mathematical library. Pandas is a library that deals with data frames. Matplotlib.pyplot is a visualization library, and Seedworm is also a visualization library, but it is more sophisticated and than Matplotlib, and it's built on the back of Matplotlib. And then after we've loaded up, imported the 4 main libraries that we're going to use in this program, we also imported OS, which means operating system, and we went into the operating system, and then we got the 3 CSV files that we were going to be using for this competition: train, test, and sample solution. And then I read the files. I used Pandas to read the files. So train equals PD, read underscore CSV, and then the path for train. Did the same thing with test, and did the same thing with sample solution. So now you can see the train data set. It has 75,757 rows by 64 columns. And the second to the last column is site underscore EUI, and that is your target. That's what we're going to be looking at. But that's interesting. And then we look at train. Train is exactly the same, except that it doesn't have the column site underscore EUI, because that's your target, and that's what we're going to be creating. And then you have your submission. So this is what Kaggle is going to want to see when you submit your work. So then I'm going to analyze the train. We analyze the train by using the describe button. So what this describe does is it goes through all of the numeric columns, and it gives you the statistics for all of the numeric columns. And then we're going to go info on the train. So it tells you the columns that are objects. So you've got 3 columns that are objects, and the rest of them are integers and floats. So you're going to have to do something with the columns that are objects, but we're not going to do it right now. Then we're going to check the null values, and when we check the null values, we have a number of columns that have null values. And so what I decided I wanted to do is I wanted to get a list of all the columns that had null values. So I did train.columns, train.isInA.any.toList. And so what that does is that makes a list of all of the columns that have null values. And so this list is year built, energy, star rating, direction, max wind speed, direction, peak wind speed, max wind speed, and days with fog. So those are all of your columns that have null values. And I just decided that I was going to delete all of the columns in train and test that had null values. So those columns were deleted. And you know what I could have done is I could have imputed them, and I could have filled them with the, could have filled them with like the median value or the mode or the average or something like that. But I just decided to just cut to the chase and delete drop the columns that had null values. So now we have 58 columns because we've dropped all of those columns that had null values. So we want to check train to see if it's null, and there's not any more null values in train. So we're going to analyze the target, which is the site EUI, and you can see that one, the target is skewed, and two, you have a lot on the right hand side. So something's going to have to be done with that. What that's telling you is there's a lot of outliers. So we're going to remove the outliers. So we put the code in here to remove the outliers. And we found out that we had anything that's an outlier that's below the 1.5 times the interquartile and above anything that's below the minimum value or above the maximum value, they're just going to convert that to a not a number. And so there's 3844 values that are just not a number. So what we decided we're going to do is we're going to drop all the rows that are not a number. And what we've done here, any of the target variables that are below the minimum or above the maximum, I just made it not a number. And then so we've dropped all of those rows that have not a number on them. And then so now what we're going to do is we're going to take the target, and the target equals train site EUI. And you can look at the disk plot again, and you can see that you have a much more evenly distributed disk plot than we had before we removed the outliers. So we're going to drop the site EUI because that's not needed anymore. And then what we're going to do is we're going to take test and we're going to append it to the train file and create a new file calling it combi. So now we're going to analyze the object columns. So we've analyzed the state factor, and then we're going to analyze the building class, and that's only two. It's either commercial or residential. And then so I decided, since the building class was only two, commercial or residential, I decided that what I was going to do is I was going to replace commercial with the number 1 and replace residential with the number 2. And then so now what we wanted to do is we wanted to check facility type, and you can see that there are lots of types of facilities, and there's too many for me to just replace the numbers. So I was going to take the two columns, the state factor and the facility type, and I was going to ordinal encode them. So what I did was I imported the pre-processing in sklearn, and then I called up and imported the ordinal encoder, and then I put it through a for loop. So for call in combi, if combi call.dtype equals object, combi call equals enc.bit transform, combi call values reshape neg1 1 combi. So what we've done there is we've taken those two columns that were object columns and we've ordinal encoded them. So state factor is ordinal encoded, and facility type is also ordinally coded. So now what I've done is I've made a heat map of all of these columns, and amazingly everything's black, you know. So that wasn't a very good heat map, and what that's telling you is that the columns don't have a very good correlation to each other. And then what I did was I normalized combi. So combi equals combi minus combi min over combi max minus combi min. And so that normalized it. And I could have standardized it, but I found out sometimes when I standardize it, it doesn't work on the model. So I decided to just normalize it, because it's easier for the model to work if the data is normalized. And what happens when you normalize the data is you take all of the data and you convert it to a value between 0 and 1, because the model tends to work better if you are able to keep all the values close together. Now what we're going to do, and one thing that I did forget to do, and we can check it as soon as I finish this code review, one thing we're going to do is we're going to define our X and Y variables. So your Y is your target, your X is your combi from the 0 all the way to the length of train, and your X test is your combi all the way from the length of train to the end. And then what I did was I split my data set, and then the test size is 0.05. Then I selected my model, and in this instance, I got a 99% when I trained the model, you know, so I got a 99% when I trained the model when I used extra trees regressor, but when I predicted the model, I only got a 17%, which is very low, and then on my RMSE, I've got a 29, you know, which isn't fantastic. And then so what I did was I created a data frame, and so you've got the actual value predicted against the predicted value, and you can see that that's not fantastic either. And then what we're going to do is I put it on a graph to compare the actual values against the predicted values. And so you can see that it's all out there, you know, it's not in a fine line like it should be. Then we predicted on the test set, and the values are float values. And I said anything less than 0 is going to be a 0, because generally when you standardize your data frame or your data, you're going to have negative values, but I didn't standardize it in this instance. I just minimized it, but I went ahead and left that code in there anyway, just in case. And then we submitted the data, and so you can see the submissions. And then what I did, you can see the submissions, that is what was submitted to Kaggle. But what I did was I forgot to check for null values on combi. I checked for null values on train, but I forgot to check for null values on combi. So we'll just come over here and say combi. So hopefully what we'll do is we'll rerun it. It takes a really long time to run it, so we're not going to sit here on the video and wait for it to run because it takes a long time. I ran it once before already. I just want to see if there are any null values in Combi that are going to affect the model. And if I have time, there's a possibility that I might do PyTorch, but that's going to be another code review. So yeah, so Combi doesn't have any null values. If Combi did have null values, then the model would not have run. But since I had forgot to check for null values, I thought, oh well, I better do that. But this extra trees takes a really long time to work through. So I'm not going to sit here with you while I work through the extra trees because it's going to take a long time and we've already worked through the extra trees before. So that is the code review for this code for women in data science, and it was a late submission, and maybe I might find some PyTorch and see if I can improve my score with PyTorch. So I hope that you received some benefit from this code review and you got some tips about things that you can do. I mean, I've been doing data science for 2 years now, and I'm, always picking up tips. But I look forward to getting some good reviews, getting some good responses. So thank you so much for supporting my channel, and if you like my video, please like, subscribe, and share, and I look forward to making more videos for you in the future.